Hey guys, today we're going to work on comparing two functions. So for the Nuke Agenda, we have three different problems here. It says what type of function is shown below. So whenever we're talking about functions, we have three different types of functions. We have linear, we have quadratic, and we have exponential. So let's see which one each one of these are. So for the first one, whenever you have a graph, it's a lot easier to know whether it's linear, quadratic, or exponential. Linear functions are in a straight line. This one has a curve. Quadratic, they look like this. They always look like a U shape. So it would have been something like this, or maybe something like that. So we don't see any of that here. So for this one, we know automatically it's exponential. Alright. For number 2, we have 5x plus 13. Now we can look at the graph by typing it into our calculator. Let's do that right now. So we have 5x plus 13. Press graph, and as you can see, there's a line. This one is definitely linear. But we didn't have to type into the calculator. Whenever we see x by itself, we know that it's linear. So for linear, an example would be like 2x plus 5. Quadratic, you see that there's a squared, so you see 2x squared plus 5. And for exponential, our exponent has the variable, so it would be 2 to the x power plus 5. So these are the differences. Since I saw that x was by itself and it was not an exponent, I knew right away it was linear. Okay, so now for the table. Now let's see if there's some kind of pattern going on here. I'm going to get rid of all of this that I wrote here. And let's see if there's some pattern. So first pattern that we should always check is adding. So to go from -4 to -8, I add -4. Okay, because -4 plus -4 gives us -8. To go from -8 to -16, I add -8. Because -8 plus -8 is -16. As you can see, it's not a constant rate of change. Since it's not a constant rate of change, it cannot be linear. Let's try if it's doubling or tripling or being multiplied by some number. Okay. So I gotta think, what do I multiply to -4 to get -8? I would multiply by 2. -4 times 2 gives me -8. And -8, let's see if this still works. -8 times 2, it does give me 16. I'm going to keep going, just to be sure. -16 times 2 gives me -32. And -32 times 2 gives me -64. Because we have a multiplying pattern here, this is exponential. Remember, exponential functions have multiplying patterns. Alright, so let's move on with today's lesson. So, we can figure out when two equations are equal. There are multiple ways of doing this. One, we can set both equations equal to each other and solve them. We can look at the table and the calculator and see what the values are. We can plug in the numbers, or we can put the equations into y equal and use the intersect button. They may ask us to figure out whether one equation is greater than another. We can look at the table in the calculator, or we can plug in the numbers. And when we're comparing the minimum or maximum, we've got to find all the minimum and maximums and then compare the numbers. Now, this may not seem like it makes much sense right now, but when we get to problems, it'll make more sense. Alright, so the first problem says, if h of x is equal to 1/2 x minus 9, and k of x is equal to -5x plus 13, it says which values of x makes h of x equal to k of x. So we want to see when they're equal to each other. So there are multiple things we can do. We can set it equal to each other and then solve, look at the table and whatnot. I think for this one, I'm going to set them equal to each other and solve. I like algebra. I like using algebra. So I'm going to do that for the first one. And then I'm going to show you how you can use the calculator. So we want to see when both of these are equal to each other. So I set this equal to -5x plus 13. Okay. Now this is going back to basic algebra. We want to isolate the variable. We want to get the variable on one side. We want to get the number on one side. So I'm going to add 5x to both sides. Plus 5x. And we're going to leave this in terms of decimals. I don't need this as a fraction. So 5 plus 1 over 2. And we get 5.5. So we have 5.5x minus 9 equals 13. Next, I'm going to add 9 to both sides. We get 5.5x equals 13 plus 9 is 22. And then the last step, we divide by 5.5 on both sides. So 22 divided by 5.5. And that gives me 4. So x equals 4. And there's our answer. Now, what we could have done, we could have taken each one of these answers and plugged them in for x and see when we get the exact same number. That does take some time, but it will always work. I'm going to also type into the calculator. So I'm going to type in 1/2 x, so alpha y equals 1 over 2 x minus 9. And the next one would be negative 5x plus 13. And I press graph. Now I see that it crosses at some point here. I can calculate it using calculate. So I press sec and trace. I want to see where they intersect, so I press 5. And I get as close to the point as I can, as possible. Enter, enter, enter. So I got 2 different answers here. I got 4, and I got negative 7. Which one's the right answer? Now, notice here, it says which value of x. Since we're solving for x, I take my x answer. And my x answer is 4. Another thing we could have done is look at the table. Alright, so I see some weird numbers here. I want to see when they're actually equal to each other. So the first one is 0. I look at 0, I see that when I plug in 0, I get 9 and 13. Negative 9 and 13, they're not equal to each other. I look at 4, and I see negative 7 and negative 7. So that seems like it's the right answer. If I scroll up to negative 7, I don't get the same answer. And if I scroll down to 8, I don't get the same answer as well. So I know that my answer is 4. Okay, so let's try this one. It says if f of x equals 4 to the x power and g of x is equal to 9x plus 7, at which value of x is f of x less than g of x? Okay, for this one, first of all, we don't know how to solve, how to get rid of this x in the exponent yet. You're going to learn that in Algebra 2. So I can't use algebra for this. I'm going to use my calculator. I can either plug in all of these values, or I can use my calculator. So let's use my calculator first. I'm going to clear these things out. And let's see. I have 4 to the x, so I type in 4, up arrow, x, and I have 9x plus 7. Now, I can press graph, and that's cool, but I'm going to look at the table. Now remember, we want to see when is f of x, when is this first function less than the second function. As you can see, with all of these numbers here, the first function is bigger than the second function. So let's test 4. I look at my x value at 4, and I see that my first function is 256, and my second function is 43. So I have to ask myself, is 256 less than 43? Clearly not. That's way too big. So that goes away. Since I'm on this screen, let's look at 7. 7. It's 16,384. Is that smaller than 70? Nah. So that goes away. So now let's take a look at 3. That's the next one right here. So we're getting closer. It says 64 and 34, but 64 is not smaller than 34. So 3 is out. It must mean our answer choice must be 1. But let's just check. So when I plug in 1, I have 4 and 16. 4 is definitely less than 16, so that's my answer. If I were to plug in all of these answer choices, you can see you're going to get the exact same numbers. But I'm just going to plug in the right answer so you can see. So they're saying 4 to the x must be less than 9x plus 7. And I'm going to plug in 1 as my answer. So I have 4 to the first power should be less than 9 times 1 plus 7. I'm going to put a question mark because I don't know if it's true yet. 4 to the first power is 4. 9 times 1 is 9. Plus 7 is 16. So it shows here that 4 is less than 16. That works. Alright, moving on. So it says, which function has a minimum less than the one shown below? Alright, so we have a minimum here, and it's all the way down here. Since we're talking about minimum, we don't really care about the x value as much, we more care about the y value. So our minimum for this one is -3. Now I have a bunch of different values here. I'm going to plug them into the calculator and see what I get. Not values, I meant answers. Okay, where we have x squared minus x plus 5. Okay, I'm going to look at this one first. Take a look at the graph. I don't even have to look at the table. I can see that that's wrong. This minimum is way lower than this one. This one is above the x-axis. This one is below the x-axis. I know that A is out. Okay. Now, for this one here, if you remember your transformation laws, we don't even have to type it into the calculator. We know what's going on here. So just to recap, for our transformation, if I have a number on the outside, this means our parent function is going up 7. And this -3 means it's going to the right 3. So what that means is that I'm going to take this function here, and it's going to go, oops, it's going to go, oh, hang on one second. Technical difficulties. Let's try this again. So this function here, it's an absolute value function, so I know it looks like a v, like this, and that's my parent function. This transformation is telling me that it's going to go up 7, all the way up here, and then to the right, 1, 2, 3. That's not lower than this one here. We want to find one that's less than the one shown here. So I know that answer choice B is also out. But let's just say I forgot my transformation laws. I can go to the calculator and just double check it. So as a reminder, to get absolute value, we press second, 0, enter. And we can type it in. We have x minus 3 plus 7. And sure enough, that's pretty much where we said it was going to be. So that doesn't work. Next one is x squared plus 4. Same thing with the transformation laws. We know what x squared looks like. So it's going to have a U shape like this. And since it's going to be plus 4, I know that it's going to go up 4 right here. That's still not lower, so I'm going to cross that one out. And finally, we have this last one here. We have x plus 2 minus 6. So knowing our transformation laws, I know it's going to go to the left 2, and it's going to go down 6. So that seems like it's going to work. Let's check it and see. Let me get rid of everything else that's here. And I'm going to draw my absolute value function again, to the best of my ability. So I start here, go down, oh boy, and then I go back up. Alright, now it's telling me that I'm going to go left 2, so right here. I'm going to go down 6, that's all the way down here. This one's clearly lower than that answer, so D is my answer choice. Okay? And again, you can check it on your calculator. I'm pretty confident with my transformation rules, so I know that this is right. Okay, so now this one says, which function has the greatest y-intercept? Now we want to see what, so y-intercept means and type it out so it's not as sloppy. So y-intercept means when the graph crosses the y-axis. Okay, and you guys learned this before when you did slope and intercept, slope y-intercept. So we want to see where it crosses the y-axis. Essentially, another helpful tip to know is that when we're talking about y-intercept, this also means it's also when x equals 0. So knowing this, we can actually just look at the graph, look at the table, and see which one has the greatest y-intercept. So I'm going to type the first one in. We have 2x plus 5. You know, I'm going to type in all of them. I can do them all at the same time. So I'm going to get my absolute value. Another way you can get absolute value is go to math, over the number, and press enter. So we have x minus 6 plus 1. We have negative x squared minus 4. And we have x squared plus 3x plus 2. Alright, I can press graph and I can see all of these different ones here. And it looks like, just by looking at the graph, let's see our y-intercepts. I'm going to pull this and bring it over here. Oh. So I'm going to make this bigger. And I'm going to show where my y-intercepts are. So I have one here, one here, one here, and one here. Okay? So we have a black line, the pink line, the blue line, and then the red line. We want to see which one's the biggest. And it looks like the red line is the biggest. Now I know, just based off of this drawing here, hang on, let's see if I can get all this together. So I know, just based off of this drawing here, this red line is going to be my answer. It's not a quadratic, because it doesn't have a U shape. So I'll get rid of the quadratics. And it's not a linear function, because it's not a line. This one here is an absolute value function, so it means that B must be my answer. Now just to double check, I know it's the red one here. For my calculator, I can go back and see that the red one is my second answer choice. And lastly, I can also look at the table here, and when x equals 0, I want to see which one's the biggest one. I have 5, 7, negative 4, and 2. 7 is the biggest one here, and that's my second answer. So those are different ways that you can find your answer. Okay, so we have this multiple choice question here. It's not 3 different questions, guys. It says, which quadratic function has the largest maximum? So each one of these are quadratic functions, but it's being shown in a very different way. Okay, so let's take a look. We have these functions. I like to deal with the table and the graph first, just because it's easier for me to see without using anything else. So we want the largest maximum. Let's look at the graph first. I see that we start with 0, then 1. Notice they gave you 1 here, so you know what the interval is. So 1, 2, 3, 4. I would call this maybe 4.5. So our maximum here is 4.5. Again, whenever they're talking about maximum or minimums, we're always looking at the y-axis. Okay, so for this one here, I see that in the middle is going to be where my biggest point is, because I see that there's a negative 3, positive 5, 9, and then it goes to 9, 5, and 3. This one here, technically it is a number just a little bit higher. Just like how this one is, where you see that it goes from 1, and then it goes to, what is that, 4? And then the next one goes to 4. In the middle here, there's still one that's a little bit higher, which was 4.5. So using that same logic, I'll say that this one, it's probably 9.5, somewhere around there. It might be a little bit higher, it might be a little bit less. I'm just estimating that the height would be around 9.5. Now let's check 1 and 3. So for one, we have no choice. We're going to just type into the calculator. So I'm going to clear everything out here. And I'm going to type in this first one. So we have 3 minus x and 2 plus x. Press graph. So I can see that there's some kind of maximum here, but I'm going to look at the table just to be sure. Now to find the maximum, we want the numbers to repeat on both sides. I see that we have a -6, we have a 0, we have a 4, we have a 6, 6. It's starting to repeat there. Let me keep going down this way. And there we go. So now we see that this is repeating. So for this table, we have 0, 4, 6, and then 6. Again, right here, we see that these numbers are repeating, but there should be some number in between. I'm going to call this one 6.5. Okay? And when we look at the graph too, we can see that it doesn't go past really 6.5. It doesn't go up to 7. So right away, I know that this one can't be my answer. And this one can't be my answer. Oops, not that. That's the answer. That's the problem. So these two can't be my answers because 9.5 is still bigger than both of these. So let's check the last one. Go to y equals and then clear everything out. -5x squared. Oops. Minus 12x plus 4. Okay, press graph. Ooh, that one goes up pretty high. Now, there's something cool that you can do. There's also a calculate button where it can calculate the maximum for you. I'm going to show you guys how to use that, but then I'm just going to look at the table afterwards. So the maximum, we're going to press 4. Now we want to go to the left. So this is the left side. We go to the right. That's the right side. I guess you want to go somewhere in the middle. Now I can't really see where that is, but I know it's going to be in the middle of these two. And it gives us our maximum right here. Our maximum for this one is 11.2. Okay, so it seems like it clearly beat out number 2. So I think the answer is 3. But let's just look at the table to be sure. So again, I want numbers to repeat. And this one's a jumbled mess. Oof. I don't see any numbers that repeat here. And the reason why the numbers don't repeat nicely is because the equation itself is a little bit wonky. But if you want to look for something that repeats, look at the negative numbers. I want equal amounts of negative numbers on both sides. So I have 1, 2, 3, 4. 1, 2, 3, 4. So that's pretty good. That's almost in the middle. And the number directly in the middle I see is 11. Right? That's the highest number that we have here. We know it's going to go up just a little bit more because we calculated it to be 11.2. But we know 11 is much bigger than 9.5. So hence choice 3. Okay, so we got some practice problems to do here. So you guys are going to do 1, 2, 3, and 4. Okay? So I'm going to leave this up for a little bit. These are the first 2 problems. If you are looking at this video now, pause it here, work on these 2 problems, and then I'm going to change it over to these 2 problems. And these are multiple choice questions. So it says which function has a maximum greater than this, and which one has a minimum less than this. Okay? Hope you guys are doing well, staying safe, and enjoying the beautiful weather. Talk to you guys next time.